A currency swap involves two parties that agree to exchange a series of payments in different currencies over a period of time. The currency swap may be fixed for fixed, fixed for floating, or floating for floating payment. As there are two currencies in the swap, there are two notional amounts that are used to determine the payments on each side. The notional amounts in a currency swap may or may not be exchanged. This is decided by the two parties in line with their respective motivation for the currency swap arrangements. Payments in a currency swap are typically not netted as the payments are in two different currencies. However, there are arrangements in some swaps to net the payment, which may involve a third party such as a clearing house. It helps to reduce the credit risk in the currency swap. Also, currency swaps are different than forex swaps. Forex swaps involve a long position in a forward contract on a currency and a short position in a forward contract on the same currency with a longer maturity than the long forward contract. A currency swap does not involve any forward contracts, though it is equivalent to a series of long and short forward contracts on a currency. To understand the mechanics of a currency swap, let's have a look at this example, which we will then use to learn the pricing and valuation of a currency swap. Reston Technology has arranged a currency swap with GSI as its counterparty. Reston agrees to pay the euro interest rate of 4.35% on a notional value of 10 million, where payments will be made semi-annually for 2 years period. The counterparty, that is GSI, agrees to pay the dollar interest rate of 6.1% based on a notional principal of 9.804 million semi-annually for the 2 years. Both parties agree to exchange the notional principal at the start and end of the swap period. Payments are netted. The payments on this currency swap are shown in figure 11.5. As we see here, at the start, both parties exchange the notional principals. Then on each settlement date, Reston Technologies pays 4.35% euro rate on 10 million euros and receives 6.1% US rate on $9.804 million. The up arrow indicates cash inflow and the down arrow indicates cash outflow for Reston Technology. The payments are calculated as the interest rate in the given currency multiplied into the notional principal in the given currency multiplied into 180 days, that is semi-annual, divided by 360 days in the year. Finally, on the last settlement date, which is the termination date of the swap, the principal amounts are returned along with the final payments for interest. This marks the end of the swap. Figure 11.6 shows the different combinations of interest rate swaps that can be created with currency swaps. For example, here, the first one is showing that a pay dollar floating and receive dollar fixed is equivalent to two currency swaps, in which the first one is pay euro fixed and receive dollar fixed, and the second one is pay dollar floating and receive euro fixed. Similarly, other interest rate swaps can be created by combining different currency swaps. Therefore, currency swaps can be used to change the nature of cash flows and hence manage or get a specific currency risk exposure. To price a currency swap, we continue with our currency swap example of Reston Technology. The notional principal are 10 million euros and $9.804 million. And if we divide $9.804 million by 10 million euros, the current spot exchange rate implied by this is $0.9804 per euro. As the swap involves fixed interest payments in dollars and euros, we will price two different plain vanilla interest rate swaps, one in dollar and one in euro currency. As we know from our first video tutorial, floating rate side will have its value equal to par value. That is, the value of floating rate bond is equal to the par value of the bond at the start. We don't need to value the floating rate side of the swap, so we need the term structure of dollar and euro interest rates to calculate the respective fixed rate. This we do in table 11.6. We know the formula for the fixed rate in a plain vanilla interest rate swap. The same formula is used here twice, as we need two fixed rate as price of the currency swap in dollar and in euro currencies. We have the dollar spot rates for maturities in 180, 360, 540 and 720 days. These are used to calculate the present value of zero coupon bonds with a par value of $1 payable at their respective maturities. In other words, these are the present value discount factors. Using the swap fixed rate formula, we calculate the fixed rate to be 6.1%. This is the same as in our example, so we now know how this is obtained for Reston Technology and GSI example. For the euro fixed rate, we use the euro term structure of interest rate for 180, 360, 540 and 720 days. Using the values of the euro zero coupon bonds, that is the present value discount factors, in the fixed rate formula, we get the euro fixed rate to be 4.35%, the same as given in the example of Reston. We know that in a plain vanilla interest rate swap, the value of the fixed rate bond should be equal to the value of the floating rate bond. That is, at the start of the swap, the value should be equal to 0. For the dollar side, the value of the plain interest rate vanilla swap is equal to 0 at the start, because the value of the fixed rate bond in dollar is equal to the value of the floating rate bond in dollars. That is, the value of the fixed rate bond in dollars is equal to the value of the floating rate bond in dollars. Our notional value here is $9.804 million. Though we know that when we value these bonds, we assume a notional value of $1. However, we know that in our case in the swap, the notional value is $9.804 million. Similarly, a plain vanilla interest rate swap in euros will also have its value equal to 0 at the start. That is, the value of a fixed rate bond in euros should be equal to the value of a floating rate bond in euros at the start. The value of a fixed rate bond in euros is equal to the value of a floating rate bond in euros. The notional value here is 10 million euros. If we want to value currency swap, we have to convert either the euro notional value into dollar notional value or the dollar notional value into euro notional value. In both cases, the value of the currency swap will be 0 when we convert the value of the fixed rate bond in dollars into euros, or the value of the fixed rate bond in euros into dollars. They will equate to the same value, resulting in the value of the currency swap being equal to 0. For example, 9.804 million of the dollar side is equal to 10 million euros of the euro side. If we convert the 10 million euros at the current exchange rate of 0.9804, that is, both are equal to $9.804 million. The value of the currency swap, however, will change from 0 once it is initiated and may be positive or negative depending on the changes in interest rate as well as the spot exchange rates on the valuation date. This will be required as we need to convert the value of one side on the swap to a common currency to get the value of the swap. In table 11.7, we value the currency swap of Reston Technology example during its life. Though we have a fixed for fixed currency swap, we also value the floating sides of the swap in the two currencies so that we can value other possible currency swaps. Remember, we do not need to value the floating sides at the start of the swap as they are equal to par value anyway. Now 90 days into the Reston GSI swap example, the term structure of the dollar interest rate and the euro interest rates have changed. Using these new dollar and euro interest rates for the remainder of the swap term, we have calculated the prices of zero coupon bonds, that is the present value discount factors for dollar and euro cash flows. On the dollar side, the fixed rate bond with a face value of $1 is expected to make interest payment at 6.1% semi-annually in 90 days, 270 days, 450 days and 630 days from now, and will also pay the $1 principal on day 630. So the present value of the interest on $1 at 6.1% over the term of the bond, that is the swap, plus the present value of $1 principal is equal to the present value of the fixed rate bond, that is 1.01132335. that is the price of the fixed rate bond in dollars 90 days into the swap. If we value the floating rate dollar bond, it will have its value equal to the present value of the interest payment 90 days from now and the value of the floating rate bond 90 days from now, which will be equal to the par value as it will be the reset date. We know that on every reset date, the par value of the floating rate bond will be equal to the market value of the bond. From table 11.6, we know that the spot LIBOR for the first payment in 180 days was 5.5%. So the first payment on the floating rate bond will be based on this rate, which will be made 90 days from now. Using this interest payment and the par value of the floating rate bond 90 days from now, we estimate the value of the floating rate bond equal to 1.013115. We have used the price of the 90-day zero coupon bond, that is the discount factor here, to calculate the present value of these two cash flows as they will occur on day 90 from now. Following the same procedure, using the euro interest rate term structure and the prices of zero coupon bonds, we estimate the value of both fixed and floating rate euro bonds here. Now we have the prices of dollar denominated fixed rate and floating rate bond with par value equal to $1 and euro denominated fixed and floating rate bond with par value equal to €1 90 days into the swap. We can now use these values to adjust the notional value in each currency and then value currency swaps using the spot fixed rate 90 days into the swap. First, we adjust the notional value of the swap in each currency using the prices of dollar and euro fixed and floating rate bonds that we calculated in table 11.7. So the fixed notional value of $9.804 million at the start will now be $9.804 million multiplied into the price of the fixed bond as we calculated, which is now equal to 9.915014. Similarly, dollars floating for a notional value of 9.804 million will be equal to 9.932579 million. This is if you are paying or receiving dollars floating in a currency swap. Next, if you are paying or receiving euro fixed in a currency swap, with a notional value of 10 million at the start, it will now be equal to 10.088308 million euros. If the swap involves paying euros floating with a notional value of 10 million at the start, it will now be equal to 10.091157 million euros, and we are using the fixed rate and the floating rate bond prices we calculated in table 11.7 to get these adjusted notional values of currency swaps. The first swap that we are valuing here is the swap from our Reston technology example. The value of this swap 90 days into its life, where Reston pays euro fixed and receives dollar fixed, is equal to $38,560. As we are valuing the swap in dollars, we are converting the value of the euro side of the swap at the spot exchange rate 90 days into the swap. The other possible combinations of currency swaps have also been valued here 90 days into the life of the swap. Note, each time we are valuing the swap in dollars, we are converting the euro side of the swap into dollars using the spot rates. You can also value the swap in euros. You will then need to convert the dollar side of the swap into euros and deduct it from the euro side of the swap to value the swap from the perspective of the counterparty. Currency swaps can be used to substitute borrowing in one currency with another currency. For example, a US firm may borrow in dollars, such as Reston Technology, and then exchange it for euros, thus effectively converting its dollar loan into a euro loan. This is shown in figure 11.7. We have just worked out this example. You can see that Reston is borrowing from the lender and then entering into a swap with GSI, exchanging the cash flows, then on every settlement date makes the euro interest payment and receives the dollar interest payment in the swap, which it uses to pay the lender. Note that Reston is making a higher payment here to the lender than what it receives in the swap. It is indicating that Reston has higher credit risk compared to GSI in the swap transaction. Now, at termination, we see that the cash flows in the swap are again exchanged, and Reston uses the cash flow received from GSI in the swap to settle the debt with the lender. What could motivate Reston to enter into such a swap? It may be because it is not able to borrow in euros for varied reasons, or it is able to borrow at a lower rate in dollars compared to euros. There are different reasons that can lead a firm to enter a currency swap. The dominant, of course, will be to hedge. However, it can be used to speculate also. A multinational firm may enter into a currency swap to manage the risk associated with cash flows from its subsidiaries. Such a swap may not involve exchange of notional values. A company may have borrowed on floating rate or fixed rate in a foreign currency and after some time may realize that it was not a good decision. Instead of living with this bad decision, the company may enter into a currency swap and synthetically change its currency and interest rate exposure to another one of its choice.